Hi, I'm Carlos Clamp. I'm a solutions engineer here with Data Virtuality. And what we're going to be looking at is our stored procedure language. At the beginning, we're going to take a very small, quick overview, and then we're going to progress into more advanced things. Can everyone see my screen and see the first slide?
Yes.
Thank you. This will be our agenda today. We're going to be looking at configuring Data Virtuality Studio. We're going to be looking at some basic concepts such as the stored procedure syntax, how to create tables inside of stored procedures, transactions, building dynamic queries, and logging. And these will be the building blocks for later concepts that we're going to look at, such as concatenating strings with JavaScript, why we would use this and how we would use this, and also related to dynamic queries and logging. We're going to look at restartable operations and also looking at putting all this together with the ability to cache the results of a stored procedure that takes a long time. Now we can put all these things together. So we're going to start first with looking at how to configure our Data Virtuality Studio. The item that we're interested in the most is auto committing transactions. So the reason we want to change this to off for this presentation is that normally Data Virtuality Studio, when you issue a SQL query, it issues it with a transaction. And a lot of the things that we're going to be looking at today, we don't want them to be completely wrapped inside of a transaction. If it fails, we want what's been processed to be written to the database. And we'll then also look at how we can force a transaction to happen. But to begin with, if you're going to follow along afterwards on the course, I do recommend going to server preferences and turning off auto commit. So the way to do that is to go to Window, Preferences, and Server Preferences, and make sure that this is off right here. And then just click Apply and Close. And now when you submit a SQL query or execute a stored procedure, it is going to be done without a transaction wrapping it. So, and this is going to be important for a lot of things that we're going to be doing next. The next thing we're going to be looking at again is the stored procedure syntax. And if you want to follow along afterwards, you have access to the files. All of these will be provided. Later on, if you want to follow along, the information that I'm going to present here is stored in the files Sprox syntax 1 and 2. So let's go and open these up. There we go, Sprox syntax 1, and open up the second one, which is Sprox syntax 2. So in Sprox syntax 1, where we're going to look at what we're interested in is the basic syntax of stored procedures inside of Data Virtuality. For the most part, stored procedures are very similar to stored procedures in other SQL languages. Data Virtuality does not distinguish between stored procedures and functions. Functions in other languages can return an aggregate or a scalar result, and or return tables. But for the most part, in some languages, stored procedures don't return any results at all. In Data Virtuality, we don't have functions. Stored procedures can optionally return results, and they can be used within a SQL statement, and they can be used instead of a table. And we'll look at this in just a little bit. But for now, what I want to draw your attention to is the syntax. So when we first create a stored procedure, we're going to use the create statement. We're going to use the keyword procedure. We're going to use the schema that we're going to be creating this in. And this is the schema here that is specifically created for this presentation. And the name of the stored procedure is Sprock syntax 01. And then we're going to have a open parentheses, and then we're going to define the parameters that we are going to be passing into the stored procedure. Optionally, we can redefine a table that is going to be returned by the stored procedure. The stored procedure can return one or many rows. It's up to the stored procedure, the implementer, to decide this. And in this particular example, I'm only going to be returning one single row. And you notice here, oh, excuse me, let me back up and restate that. Stored procedures will return one single result set. So even though in this stored procedure, we have two select statements, and you would think that this is going to cause the stored procedure to return two result sets, it will not. It will only return one result set, and we're going to see in just a moment which one it returns. So these stored procedures I've already created, and this is why you can see here I have an alter statement instead of a create. And this is how we go through and we edit a stored procedure. Once we have created the stored procedure, any changes we want to make to it, we're going to have to issue an alter. So we just change the keyword create to an alter, and now we can modify this stored procedure. And again, going over the basics here, and we're going to be building on this a little bit later on. So the first thing we're going to do is we're going to test this, and we're going to test this running this command here. And the only parameter that we are forced to include is the value 1. And the reason is that we have specified not null. These other values, values 2, txt, and text length, these are optional because we have not used the not null modifier. So these other parameters can be null. And we can see that here in the way we're calling this. So the first time we're going to call it, we're going to try to pass in a null to value 1. As we can see here, the system automatically warns us and throws an exception. And now we're going to properly call this, and we're going to provide a value to parameter 1. As we can see here, the internals of the stored procedure are actually very straightforward. We have a parameter text that we've defined, that we've defined it as an out. Typically, the parameters that you pass in are going to be in parameters, meaning that you pass these parameters in from the calling code, right? So here we are passing in the text, a string, into the stored procedure, right? So these are in parameters. Out means that this value does not read the parameter that's passed in. It only exports a value out to the caller. We can have parameters in our stored procedure that you can pass values in and also return values to get values out by using these. As you can see, the internals of the stored procedure are actually very simple, right? We have the parameter we passed in, which is text here, and we're just going to assign it some text. And for text length, because it's an in out, we're not actually using any value that's passed in. We're simply setting text length to the length of the text. And then for our result set here, we're simply executing these two select statements. Right? So you can really see here that these two values, really the assignment to the text and the select statement, really don't have anything to do with each other. These are mainly just for examples here during this this course. So again, when we execute this stored procedure, what we're seeing is that it's returning the second result set that we issued. It doesn't mean that it automatically combines the first and the second. It simply means that if the stored procedure detects multiple result sets that are going to be returned, it will only return the last one. So this is very important. So if you're creating a stored procedure and you begin to run into problems where it's not returning the results that you expect, it is probably because there's another piece of code that is returning a value, and that is the one that is going to be returned by the stored procedure itself. So let's look a little bit more at how we can leverage this, right? So again, we're going to use our first stored procedure here, and we're going to build a second one. And what this one is going to do, it is simply going to call the first one. And again, we're going to do the same thing. We're going to call both of these stored procedures, right? And we're going to see what the result is going to be. And if you have a guess as to which one it's going to be, and you're guessing on this last one being executed, you're absolutely correct. So again, we're running into the same problem, right? We're expecting this first one to get returned, but since the last stored procedure we executed also returns a value, it is overwriting the result set from this one, right? And it's actually this first call that we want. So what we're going to do is going to comment that out, uncomment this line, and we're going to add in the modifiers without return. So what we're doing now is I'm going to execute this, alter our stored procedure. And now when I call this, it's returning the first call. So what did we do exactly? So what we're doing here is we made the call to the first one. Internal, this is not exactly how it's done internally, just it's a figurative explanation. So the first one, the first stored procedure call returns a result set, in the stored procedure holds on to that result set. Then when it makes the second call, right, it sees that there is the modifier without return, and it completely ignores the result set. And this allows the first result set to be returned. So why is this important? Because if you're calling stored procedures from within other stored procedures, it is important. You might get an error saying that the result set does not match the definition of the result set defined for the stored procedure, right? That this result set here doesn't match this one, right? And so, and as a beginner to writing stored procedures, this can be a little off-putting because it's kind of hard to understand what's going on and why we would need this here, right? So hopefully this will prevent people from running into this and prevent some headaches. And again, if what you want is simply to build a stored procedure that does not return any results, we're going to use stored procedure number 3 here as an example. And it's identical to number 2, except I've commented out the return statement, and I'm only making one stored procedure call. So when I call this third one here, as you can imagine, it doesn't return anything, right? Because we haven't specified what the return structure is, right? So it's very important, if you want to return an argument or a result set from a stored procedure, you really need to define the result set. And if you get an error that there's a mismatch, it is probably because you made a call to a stored procedure and you forgot the without return. So this is pretty important, and it kind of forms the basis of what we're going to be looking at later on. So I want to make sure everyone is, we're all on the same page and everyone is following. So I wanted to take a quick moment to ask if there's any questions or anyone has any comments about this, or if there was something I didn't explain well. And if anyone is typing, I'm going to quickly move on and I'll come back to this in just a second. I don't see that anyone is typing anything, so I think everything is going well so far. And also, if everyone in the audience is pretty knowledgeable and this is all pretty basic, I can speed up and go through this a little bit faster. But I just do want to make sure that the basics are covered and we all have the same knowledge to begin with. So the next thing we're going to look at is we're going to dive more in depth into passing parameters, and specifically returning parameters out. So this is a feature of the data virtuality syntax. Currently, we have a regression in our system, and the out parameters are not working. So you're going to have to use the return values here. And this will be fixed in one of the next releases. But I wanted to bring this to your attention in case you come out of this and you're looking forward to using out parameters in addition to result sets. I want to kind of clarify some of the problems you might run into, at least in version 2.4.14. I don't have an ETA yet on when this is going to be resolved, but the development team is aware of this. So here we've defined the stored procedure. Again, a very simple stored procedure. And the stored procedure simply takes in some text. It's an input parameter, and it cannot be null. So we always need to specify something in order to get it to work. We're going to have an output parameter called a text, which is our anonymized text. And also we're going to return the length of the original text. Now, how is this going to work? So in addition, we're also going to be returning a result set of anonymized text. For a text, what we're going to be returning as a parameter, we're simply going to be taking the original value. We're taking the first character on the left-hand side, putting in some asterisks, and taking the character on the far right. So we won't be able to really make out. All we'll have is the first letter, asterisk, and the last letter. Then we are going to take the length of that string we just created and assign that to the parameter text length. And then to return the anonymized text, we're going to return it. We're going to call it in the select statement, and that is going to be the data that is going to be returned as the result set. Right? So let's see how we can do this. Oh, and by the way, one thing I want to talk about is code blocks. So if you notice here in the stored procedure, our stored procedure definition always begins with a code block. And you can utilize code blocks, right? So similar to a stored procedure, except that you don't have any input parameters. But you can use this if you want to test something out, or if you want to write something similar to a stored procedure and you want to be able to declare variables and make calls to other stored procedures and execute code. You don't have to necessarily create a stored procedure. You can do it here. Just be mindful that there's in this code block, there's no way I actually pass in any parameters. So what we're going to do here is we're defining our variables, right? Our text, our original string that we're going to pass in, our variables that are going to have information written to them, and we're going to execute this. Right? So once we execute this here, we're going to see our results down below. And the reason we see this is because we executed a select statement here, right? So we want to return the results of this, right, of the output parameters. And as you can see here, our original text, long text string is right down here. Our result is null because we didn't assign this. We only made a stored procedure call, right? So that hasn't been set. A text now has the anonymized text, which is the first letter and the last letter and asterisk. And it also has the length. So this is where the bug is right here. So currently there's a bug, a regression in the system where you can't return the result set and the parameters at the same time. So when we run this quick code block, right, we can see that the result set is correctly being assigned, right, here, but the two output parameters are not being assigned, right? So just bear in mind that if you want to use this feature currently in 2.4.14, It is broken, but this is something that is going to be fixed soon, and you'll be able to use this feature. The other thing I want to call your attention to is how we called the stored procedure, right? So here we called it, and because we didn't want to return this value, we put in the without return modifier. And here, because we want to store the result of this stored procedure in this variable, we wrap the stored procedure call in parentheses. And that allows us to take the result set and use it and assign it as into a variable. And in this last one, what we're going to do is that we're going to call this stored procedure in the form of a select statement, as if this were a table, right? And one of the things you're going to notice is in the select statement, we're simply going to put in the select statement from. We're going to wrap this in the parentheses, and it's important and required that you have a alias for this, right? So when we run this here, we can see now that we are simply using this as if the result set, as if this were a table, and is returning the anonymized string. So this kind of completes our basic coverage of this stored procedure syntax. Is there any questions? I see that we have a question. How do you assign more than one return value to different variables? So we don't actually support this at the moment. Right now, if you wanted to assign multiple variables, the way to do it would be to store this into a temporary table. And let me copy this here. One way to do it would be
Carlos,
yes.
Sorry to interrupt, but Colin has a question. He's asking, how do you assign more than one return values to different variables?
Yes, I'm answering that right now. Thank you. So Colin, to continue with the answer, it's not currently supported. The automatic unpacking isn't supported. So the way to do this would be to assign this. One possible way to do this is to assign the result set into a temporary table, and then from the temporary table, extract the individual column values. So here, then we would assign this into temp, and then from temp, I could use anonymized. From the temp table. And use the same result in case we were returning a multi-column result set. This would be one way to do it. And then we would essentially be storing the data or the result set into a temporary table here. And one of the important things, if you're using a temporary table in this fashion, it's important to use the pound sign at the beginning. And then you can access the individual columns or use a loop and with a cursor and iterate through every single row and every single column. So I hope this answered your question. If it didn't, please let me know. There aren't any more questions. I'm going to move on to our next topic. And if there are, please let me know. Yes, please let me know if you'd like me to come back to a topic, or as we progress further, you realize that you missed something during the initial part of the presentation, or something is unclear, feel free to ask questions at any point. So the next thing we're going to look at is our ability to create tables. And this is going to be important. It's one of the most common things that we're going to be doing. And there are some nuances in creating tables inside of a code snippet inside the editor and data virtuality studio and within stored procedures, right? So we're going to begin by looking at some of the nuances here. So essentially, there's a few ways to create tables inside of Data Virtuality Studio. The first one is you can create a table simply by using the very common create table statement. And one of the things inside of data virtuality dialect is that you can specify what your primary key is going to be, right? Simply by adding this at the very end. We can do the very standard select into, shown here. We also have the stored procedures, prepare target table, create table, and these are wonderful stored procedures to assist in creating a stored procedure. And we're going to see why we need these and when we're going to use them. Also, if you need to delete the content of a table in a system, I do recommend you use the clean table. The truncate statement isn't always supported in all of the data sources, and the clean table is something that can help you out with managing the various different syntaxes and methods for deleting data from a table based on your database or your data source, right? So BigQuery syntax might be a little bit different, or Redshift, or Snowflake, or MS SQL. The syntaxes for deleting the data might be a little bit different. So I do recommend using the clean table. The final method that we're also going to be looking at is dynamic SQL and issuing an execute immediate with a text string representing the code we want to execute. And again, we're going to use the modifier without return. And we're going to see in a little bit what this looks like and why. So the two, if you want to follow along, if you're following along after the presentation, you can look at the files, create tables 01 and 02. We're going to open those right now. And we're going to open create table 02. Okay, for create table 01, we're going to look at the basic methods that we just went over in PowerPoint, right? So if table 1, and also in our drop syntax, we do support if exists, right? So there's no need to really check to see if the table exists and then drop it. So we do support the drop if exist. So here we're going to simply say, if this table exists, please drop it, and then please create the table here. So when we go to DWH, or my analytical storage, and I refresh, this is the table I just created. You can see here it's got column 1 and 2 with the data types, and also it has a primary key created. Right? Very convenient. Also, here we're going to look at, we're going to drop table 2 if it exists. And now we're going to select from table 1, from test 1 into table test 2. And again, very similar syntax to what's found in other languages. And again, here are the same tables been created. It doesn't have an index. So one of the important things to remember is, even though table test 1 has a primary key, when we created table test 2, it has the same column structure, but it doesn't have the index that we created on table test 2. So this is very important. So if you do this, you're going to have to add the index later on for the primary key, or you're going to have to use this create table syntax here. So the next thing we're going to look at is our stored procedure, or stored procedure utilities, prepare table. And the way you're going to do this is you can either specify for the source object, you can specify a pre-existing table. In this case, we're going to use a slightly different syntax, right? We could have used dwh.test1 for our source object here, but instead, if I add the $, and then I specify column 1 pipe and the string data type, and then a comma, I can specify the definition of the table. I'm going to say that this is, it is a source table. And the reason I do this is because if this is false, what it indicates is that this is going to be a table created from the result set of a stored procedure call, right? So a very handy method there. And then I'm going to say that the target table name is test1, And if it exists, I'm going to drop it and recreate it, right? If I leave this, or if I use delete, it means that if the table exists, it's going to be the contents are going to be deleted, but the table is not going to be created, right? So it's only going to be recreated if you specify drop. Or if there's null and it exists, then no operation is performed, right? So we can see here, I execute this. It goes through, it gives us a result set, tells us what it did. And when I go here and I refresh the data source, and I look here, yeah, strange. Let's see, I was looking at the wrong one, sorry. So we can see here in table test one, we can see here that we have columns 1 and 2, same as before. But now, if we notice, we no longer have a primary key associated. And if you're using this utility to create the stored procedure, there's no way to create the primary key that I know of. Again, the next one we're going to look at is the create table. And we're going to drop it in case it already exists. If it already exists and we execute this, nothing's going to happen. So here, we're going to execute the stored procedure. We're going to create the table again. It's created table test one. If you notice, we're also using the same syntax as before for defining the column types and the column names. We go here and we refresh. You see it has the same column structure, and again, it does not have the primary key. And for cleaning this table, we're going to use the drop method. So when we go here, we'll look at this. It's now been deleted, it has now been dropped. We also have the ability to use the delete method here. So if we recreate this table, we see it currently exists. And now when we execute the clean table, automatically in the background, it goes through and it issues a delete statement. So if we look at our query history, we would see, oops, that's the job history, wrong one. Show our query history. We can see now what was actually being called. And internally, this issued a delete in the background. So the next one we're going to look at is the create table statements inside of stored procedures and what these limitations are and how this works, right? So right now, we don't have any other statements other than just the drop statements, right? So if we update this, and now we go here and execute this, nothing's really happened, right? We dropped the tables that we had before. Now we're moving on here. So let's begin with commenting out, removing the comments. And we're going to alter this, edit this stored procedure. If you can see here, we have our same create statement as before. So let's see what happens when we attempt to run this. We're going to get an error because it failed to parse the query plan. So, and the reason for this, well, it's a pretty in-depth explanation, but about the parser. But essentially, the parser itself is not expecting to see any create table statements from within a stored procedure. So if we want to execute this statement, we actually have to use dynamic SQL. This create statement is going to be a string that we're going to pass into execute immediate, and we're going to execute this without return. If you're familiar with execute immediate, it can also be used to dynamically build a result set, and you can specify the form of the result set here. And you can find this inside of our documentation. Let me just open that up really quick. And we'll be picking up speed in just a minute after we've gone through the basics here. Oops, wrong one. Here we go. As you can see here, the execute immediate also has the ability to dynamically update and dynamically create a new data set. So we could, in theory, if you wanted to, you can execute a stored procedure and specify what the result set was, or in fact, you can even store the results of that SQL query you executed into a table, and you can pass in filters. So I'm not going to go over this page. This is available for you to look at later. I see that we have a question. And the question is, what is the advantage of using create table and prepare target table over normal SQL? The advantage here is the ability to be able to use these inside of a stored procedure. So because of the stored procedure, we cannot execute the create table statement from within the stored procedure. We either need to execute this as dynamic SQL, or as we're going to see a little bit later on, you can use those prepare statement and create stored procedures in order to create your tables. So that is really the big advantage of being able to use those, or else we're going to have to write dynamic SQL and put in the SQL statement. So that's really the only advantage as far as that. I hope that answers the question. And it's kind of what this has been leading up to, is that those stored procedures exist, these utility stored procedures exist to provide an easier way to create tables within stored procedures so that you don't have to resort to using dynamic SQL. So that's really the advantage, and really one of the reasons why they exist. So here, now that we've modified this, we can run the statement, and we can see that this is been run successfully and has now created table 1. Right? So again, we could have used this statement right here also, if we didn't want to use dynamic SQL. Right? And again, one of the important things is for statement inside of a code block, inside of a begin end code block, it's only a single semicolon. This is very important. So we could have done this in this following way. Just enter and execute this. And we can see that this still exists and has now been created. And also when we are running, oh, by the way, a great feature is if you hold down the control and the slash key, it will dynamically add comments. So we're going to run this. And now we're going to test our select into and see if this works from within our stored procedure. Right? So the select intos work correctly. It's simply the create statements that don't work correctly from within the stored procedure. Right? And again, we could also use this as dynamic SQL and simply execute this statement here dynamically, and this would run the statement and would be achieving the same thing. The next thing that we're going to look at is our ability to create local temporary tables from within a stored procedure. So we're going to edit our stored procedure there. We're going to run this. As you can see here, we've just run into a problem, and we weren't able to create our stored procedure. And the reason is this modifier right here, the not null. This is not allowed we're not allowed to specify the not null modifier when creating temporary tables. So we have to comment that out and remove the not null. Now let's try executing this again. So now we were able to create table test 3. It's a local temporary table, so it only exists within the scope of the stored procedure, and it disappears once we are done with it. Right? So one of the things I want to look at is our ability to create primary keys on our temporary table. So let's see if this is supported. So here we can see that we can create a primary key on our temporary table. And also, let's see if the select into is supported with a temporary table. And this is also supported. There was no error issued, nothing happened, right? And if we wanted to, we can insert a value in here. And we can double check to make sure that values are being correctly inserted into our temporary table test 4. So let's modify the stored procedure again and run it. Oh, and because I did not specify a return result set, it didn't show up. So let's quickly do that. Returns. And it's very simple. We can just take our data types here, copy these, place these in here, remove the pipe. Let's modify that. So let's want, so again, we're having different problems, right? So we created these, but we're not returning the result set. So let's try again. Still getting, indicate that the statement should be returned, right? Or without return. So one of our statements here is causing a problem, and it's going to be this one right here. The result set from create table does not match, right? So if we execute this just by itself, we can see that the result set doesn't match our expected result set. Let's look at that error again, right? Right? Our table create table limitations does not match the result set from the returnable create table, right? So it is suggesting here that we use this with a without return. So let's just copy this here and add this to our create table. Right? And I'm intentionally going through and running into these errors on purpose so that we can kind of see how to troubleshoot these quickly. Right? Okay, so now it works. And as we can see here, we inserted these test values into table 1, test 1, table test 1, excuse me. And then we did a select into our temporary table, test 4, and then we returned the result set. And this is the result set that is being returned by the stored procedure. As we can see here, we got the expected values back, right, which are the values from this right here. So this concludes this portion here that we looked at on stored procedures and creating tables. So this is pretty much the most basic part of the presentation. And I know we spent quite a bit of time on this, but it's important to understand the basics and have the syntax. So if everyone is with me, or if there are any questions, please let me know. If not, we're going to be picking up the pace a little bit from here on, now that we have the basics covered. And we're going to quickly go through transactions, dynamic queries, and logging. Okay, any questions? Anything? So I have a question from Tony. Are tables in DV equivalent to materialized views? No, they are not. Tables are truly the equivalent in other SQL dialects. So the table that when you issue a select statement from a table, reading from a table, that data is actually being read live from the data source. So if I had Postgres or Oracle or some other data source here, and I was reading that information, it would be sent live. The only time that the views are materialized is when we explicitly do this. So if we had a view here that had data, right? So if I do view 500 rows from this view, right? And then I specifically went through and said, oops, this one right here, right click materialize. That is when the contents of the view are written to analytical storage here. And that is the only case when it is a materialized table or becomes a materialized table. So I know in other databases and SQL dialects, there is a distinction between a view and a materialized view. And that is defined using that database's specific syntax. But for data virtuality, the only time you have materialized objects, and it's not limited only to views, but it can be tables within a data source. So if we had other tables here inside this data source, we can also materialize these. And what that meant is that these are then cached to analytical storage, and that when we do a read to these objects, it is transparent. The end user does not know that the result sets are cached, but transparently, if you were to read a view here from this data source, transparently to the user, it would be actually being read by analytical storage, and it would be bypassing the data source. So I hope that answered the question. So please let me know if that that worked. Okay, so the next thing we're going to look at here are transactions. And we're going to be picking up the pace here. So basic concept of a transaction, this is taken from Wikipedia, is the basic concept of a transaction is you begin a transaction, you execute, make changes to data, modify things, manipulate queries, delete tables, create tables, things like that. If there's no error, then those are committed to the database. And what that means, once you say they're committed to the database, what we're actually saying is make them take effect, right? And so all of these operations to the data are typically not visible to other users or other queries, right? And once we commit the transaction, those changes then become visible to other users, right? And this is then most part, right? If there is an error inside of our transaction, what is going to happen is that the transaction is going to be rolled back. All of those data manipulations, changes, drop tables are going to be restored. Tables that were created are going to be removed, right? That means that is the meaning of rolling back a transaction. And if you're following along later afterwards, you can look at the file transaction01. We're going to take a look at that now. Let's close all of our views here and open up transactions1. So we're going to go through this very quickly, right? So here I'm creating a table called transaction01. And if we notice here in analytical storage, all of these examples are using analytical storage for ease of implementation. So remember, if you choose to run these on your system without modifications, just remember that it will be creating and deleting tables out of analytical storage, right? So what we're going to do here, if you notice, one of the things is whenever you have a code block, this is going to be the equivalent in other SQL dialects, do a begin try, begin catch, and a begin catch exception. Excuse me. So what we're saying here is that when we begin this code block, we're going to use the keyword atomic, and that this is going to start a transaction. Again, if you are just now tuning in, it is very important to set your preferences in your schema to have auto commit transaction to off, right? We don't want Data Virtuality Studio issuing transactions that we don't to issue sorry, excuse me, got a little tongue tied. Need a drink of tea, 1 second. So we do not want Data Virtuality Studio wrapping everything inside of a transaction. We want to specifically issue a transaction or not issue a transaction. We want to be in control. Right? What we're doing here in this stored procedure, we are saying we're using the keyword atomic, and then we're saying that we are going to wrap this inside of a transaction. And here we're intentionally going to throw an exception because we're going to attempt to divide a 1 by 0, which is going to throw an exception, and it's going to roll back this process, right? And if this works correctly, as we were expecting, transaction 01 is not going to be created, right? So let's go through. We've already created the stored procedure. And we are now going to execute this transaction. Again, we get a divide by 0. And once we go look at DWH right now, there's no transaction table. So it worked as expected, right? We used keyword atomic, we created a transaction, we executed statements within the transaction, and once an error occurred, everything inside the transaction is automatically rolled back as if it never happened. Okay, so this is working exactly as expected. So let's try something different, right? Let's use not the keyword not atomic, which is the default. If you had simply the key, if you created your code block with just a begin, by default, it is using not atomic, right? So let's see what happens here. So again, we get a divide by 0, but was the table transaction 2 created or not? Let's see if you guessed correctly. It was created. So what happened? What was the difference? In the atomic case that we had a transaction, right? This one had a transaction. We created the table. We encountered an error, an exception, and then we rolled it back and we removed the table transaction 1. So I have a question from Colin. Can we have nested begin end blocks with some of them being atomic? Yes, but there are caveats. The caveat is if you have, once you create an outer transaction, everything inside of it is going to be wrapped in a transaction. So there really is no nest concept of nested transactions with some of them succeeding and some of them failing. Once you wrap a code block inside of a transaction, everything within that is going to be wrapped in a transaction, right? And if that outer transaction fails, everything inside it is going to be rolled back. Does that answer your question? And this actually brings us into our next code snippet here, which is talking about nested transactions. So here in our outer transaction, it is not atomic, right? So there's no transaction. And when we call this one is going to be wrapped in a transaction. And this is going to be transaction table is going to create table transaction 03A. And the second one, again, is atomic transaction. And it is going to be creating table transaction 03B. And there's going to be no exception, right? So what we're expecting here is that this is not going to throw an exception. Excuse me. This is going to throw an exception. It's going to be caught and it's going to be rolled back. And in this one that is atomic, there's no exception, and this one's going to be created. So let's see what happens. So let's go to DWH. Good. And as we can see, table transaction 3A was not created. Okay, so let's go back and dissect this a little bit more, right? So to begin with, there's no transaction, right? Here we create a transaction and we say that this is going to be atomic. And if there's any sort of exception, we're going to roll it back. And in the second one, we're saying that is also, we're also going to use a transaction, but we don't have the select statement that is causing the exception, right? So that's why the number 3 gets created. So what happens if we put it in not atomic? And while we're at it, let's make sure that we drop these 2 tables. Drop table if exists. We're going to do 3A and 3B. And we're going to drop these tables just to make sure, right? And we're going to put these inside the not atomic. I'm going to drop, actually, let's put them outside. We'll make these a little bit clearer. Let's put them here. And remember, when these are outside of a code block, they need to have the 2 semicolons. All right, so we're going to delete our tables again, start over. We're going to refresh. So table 3 is gone. All right, so let's see what happens now. Okay, we still ate the exception, but let's see what got created. So now we have table 3A and 3B. So why did this happen? Right? So we said that this whole thing is not wrapped in a transaction. The only one that is being wrapped in a transaction is 3B. Right? So it created 3A. And then because this is not wrapped in a transaction, it got rolled back. No, excuse me. Because this is not wrapped in a transaction, this statement was called, an exception occurred, but because there's no transaction, it still created the table. So table 3A and 3B are created, right? Okay, so let's drop these 2 tables again, and let's wrap the whole thing inside an atomic statement, and also wrap this one inside an atomic statement, and see what happens. So now when we run this, what gets created? Okay, so 3B is created, right? So what happened? We have a transaction at the very beginning. We have a transaction here, which means that this got rolled back because an exception occurred. And this one does not have an exception. So this one got created, right? So you can play around with this, and these will be in the examples. But for the most part, the nesting of transactions, the outer transaction is going to be the one that is going to be used in the entire commit statement, right? So we're going to move on to our next topic. Our next topic is dynamic queries, and we're going to go through this very quickly. For the most part, there's 3 broad categories for building dynamic queries, right? It's the additive method where you use string concatenation, right? So say you're building a select statement, you're going to build a select statement, then you're going to append to that your columns, and then you're going to append to that your from statement, and then your table names. The replacement method is essentially the select statement, and you're going to have tags inside your string, and then you're going to replace these with specific column names or specific table names. And then there's a subtractive method on, and this one I'm going to owe you. I could not find the code, and I'll be posting a community help and a video later on at the end of the month, and this will go into more detail and depth about the subtractive method and have the code available. So what we're going to use here is, in the subtractive method, the entire query itself and the variations of the query exist, and we're going to also use string concatenation replacement, but we're also going to use regular expressions to delete entire blocks or snippets of code. And it's these regular expressions that I was not able to find, and I'm going to have to do this as a separate talk and community article later on at the end of the month. So we're going to look at these 2, and this third one is going to have to be pending until the end of the month. So let's look at how this would work. So for the various examples here, we're going to look at some other code that we have. And what this does is, here we go. So this here would be an example of, whoops, I wanted to look at the contents. So here we're doing a combination of things, right? In this first one, we are using replacement. We have the entire snippet. We're using a combination of replacement and the subtractive method, right? The entire stored procedure or the entire dynamic creation of a stored procedure, the stored procedure already exists. It exists in its entirety, right? And what we're doing is once we have this code snippet already created, we are simply replacing bits and pieces of it, right? So these are the elements that we're going to be replacing: the columns, the metrics, the elements, right? And the additive method we're also going to see here, right? So in the additive method, when we're building strings, these strings here, we're simply concatenating the strings, right? Or if I'm building something, I am simply concatenating the string and I'm adding more things to it. And this is what we mean by the additive method, right? So if we were to build this entire stored procedure using the additive method, you would see bits and pieces such as the create procedure, right? And then you would see a string concatenation using the schema name and the new procedure name. These would be concatenated. So it would look something similar to this here. Oops. Right? It would look something similar to this, where we have the end of this and we would have our string concatenator and we would have a variable. And this would concatenate here. And then we would concatenate this over here. And that would be the end of our string. And as you can see, this gets to be a bit more tedious and longer, and is why sometimes it's recommended that you use the subtractive method. Create the entire thing, and if there's anything you don't need, delete it or remove it or replace it. So at the very bottom, we have these bits and pieces of text that we're going to be replacing out. And what this is going to look like at the very end, we have a replace statement for each one. Here's our template, our big template. And here is the schema. We're going to replace all instances of new schema with our new variable, right? All instances of the tag new proc name with the new proc name. And these can occur multiple times, not just limited once, right? So we have the new proc name is used in multiple places here. It's used here, and for instance here, it's also used in here, and it's used in various other places, right? So this is an example of the added subtractive method, where everything already exists and you subtract from it, right? So that's this one here. And a combination, and again, as we mentioned before, the replacement method simply uses replacements, and the subtractive method, really what you want is to build your entire query and then replace bits and pieces or delete bits and pieces of it. And again, I'll be providing that. I'll be providing the code and the regular expressions to do this at the end of the month. The next one we want to look at quickly is the logging. And the file we want to look at is logging01. And here we have a very simple start procedure. It takes a start date and end date, and it iterates from the beginning, from the start date to the end date, and it creates a set of dates, right? We told it to begin from the 8th to the 11th. And one of the things I do recommend if you're dealing with dates to use our literal, escaped literal syntax, right? You can find more information on it here. So I'm not going to dwell too much on that. There's a bunch of pros and cons. There's a bunch of pros to using it, mainly if you're used to other dialects where you simply type in a string like that and the system automatically converts that to a date. Data virtuality does not do that. If you specify a string, it believes that you intentionally meant there to be a string. And when you attempt to compile this, you will get an error saying that there's a conversion error between the string and the date, or if you're using this in the where clause, you will have degraded performance because the system is converting all of your date into strings and then comparing it against this, which is not what we want, right? We want this to be converted to a date. So I do recommend using the escape literal syntax. And the thing that we're interested in here is we want to log the information, right? Every time we do something in our system, we want to log this, right? And there's a couple important things. One is the logger name. By default, it's going to have its own logger name, and I am specifically saying that when Data Virtuality writes this to the log, I want it to have this ID, right? And I'm saying that this logger name, I'm basically saying the name of this logger is going to be DB logging example. I'm going to set the level to debug. And at the very end, I'm going to remove this, right? And anytime that I write to the log, I'm going to specify the context is going to be my logger name again. And it's very important that when you make this call, it's without the return. So let's alter this and run this system right now. And this time, oops, I forgot to run my logger here. 1 second. So what I'm going to do now is truncate my server log. Do not do this on your production system. I don't even recommend doing this on your development system. Just doing it now for the sake of this class. So I want to show what the server log looks like. It's currently empty. The size is 0. I just truncated it. And now what I want is I want to run this script here. What this script is going to do is going to monitor my log and see when I am issuing a log that has the name DB logging example. Okay. So when I go back and I run this again, let's see what it put out. So now it was run 4 times, which corresponds to our inner loop, and it will now log this information here. And again, it's very important that you use and you name your logging, right? And you set your logging priorities accordingly. Right? So this concludes our session on logging very quickly. And the next thing that we're going to look at is concatenating strings with JavaScript. So again, we're going to begin picking up speed here. And the stored procedure I want to look at is this one. A lot of databases already include a stored procedure or function that can do this. Essentially what this does is it is a veridic stored procedure that has a veridic parameter. And what that means is that you can call this with a separator and an array of strings. And what it's going to do is going to call out to JavaScript, and it is going to join these into a single string. And if there is a null value or anything like that, it will automatically join that as a pipe. So let's see how this works. We'll see how this works in just a second. One of the things I want to call to your attention is here, the veridic keyword, which indicates that this is going to be a veridic parameter, and that variadic parameter. And it is going to accept more than one or more values. And when we are converting this in JavaScript, hopefully if we get your votes in for the next masterclass, we can have something on calling out to JavaScript, R, and Python. So please let us know if that's of interest to you. So what we're passing in is we're saying that this stored procedure object table, we're passing in the language JavaScript, and we're passing in a script in JavaScript. and we're passing in two parameters to that script. We're passing in data, which is our variadic data, our variadic parameter, and we're passing in our separator. And as you can see here, these two, we define an array inside of JavaScript. We, in our variadic parameter, we're calling getArray and assigning that to our array. And then we are calling the Java language string, and we're calling the function or method join, and it joins all of the values inside that array with the separator, right? And the value that is being returned here is going to be in a column called concatenated. So when we execute this, we pass in the separator, one or more parameters that are the objects that we're going to concatenate, and then we'll return a concatenated string. So the reason I'm going through this, and I'm going through this very quickly, is that this is going to be important in the other stored procedures that we're going to look at, right? Because we want to be able to get the signature of a table or a row. So we'll see how this works in just a second. So the next thing we're going to look at, whoops, excuse me, is how this actually works and how this process actually works. So we're going to have a separator, and we're going to use the pipe. And for the data, we're actually just going to put in the digit 4, a string called foo, and we're going to pass in a null. And also we're going to remove the separator keyword. So when we execute this, this is what's going to result. We're concatenating all of these values into a string separated by the pipe. Right? And again, this could be other different data types, 4.56. And we run that, we get this. So why is this important? Why are we going to use it for? So the reason we use this is when we want to create hashes or indicators of uniqueness, right? So when in the examples that I provide, one of the things that you're going to see here is that the sales order detail is inside a CSV file. You're going to, when you install this, you're going to copy this to someplace accessible by your system. You're going to redirect your DV output to that folder. We're going to read the contents of that CSV file. We're going to parse that. And here we're going to do something interesting, right? We're going to call the utility concatenate. And this is going to create a string, a very long string with all of these values concatenated, separated by the pipe. And if you were using this in real life, in production, that string can be just enormous, right? So you don't really want to keep that string around. What we're going to do is we're going to create a hash of that string, and we're going to convert that to a character. So when we run this here, this is what we're going to see. This hash represents the unique signature of the variable of the, a unique signature of the column values, row ID, sales order ID. And as you can tell here, any variation here creates a very drastic change in your hash, right? And the probability of a collision or having duplicates is very, very low when using a hash of 512 bits. So you can use this to begin detecting similarities or monitoring when any of your values change inside of a table. And we're going to be looking at different uses of this in a little bit. So hopefully this was clear to everyone. And if you have any questions about how this is working, again, hopefully in the future, one of our next topics is going to be more on calling out to R and Java and JavaScript and Python. So we'll have a more in-depth masterclass on how to pass in parameters and how to troubleshoot these. So the next thing we're going to look at is restartable operations. So this has kind of been one of the culminations of our system here, right? So I'm going to close all of these. And I'm going to look at the file called restartable. And what we're going to be doing here is we're going to be processing this file inside of our analytical storage. This is the same data. It has all the hash files and the signature. Right. We're not going to be using the hash of these files at the moment. This was only included so that you can so as an example of how the unique combination of these column values results in a unique signature, right? That was the whole purpose of this. What we're interested in here in this example is that the column processed is going to indicate whether this has been processed or not. So again, if you notice here, we are not specifying we're not using the keyword atomic. So this means that this is not wrapped inside of a transaction, right? And we are setting up our logger. It is always a good idea if you're setting your logger information and you're running this multiple times to wrap this in a try catch exception handler and eat the exception, because this could already be set, and the second time that you call it, it will result in an exception, right? So we're just going to eat this exception here. We're going to loop over all the data. And as we process one of these, we are going to sleep. We're going to pretend this is some time-consuming API call. And we're going to randomly check if we're going to produce a random error. If we don't produce an error, we're going to log this as a successful API call, right? And then we're going to pass to our update statement here. And we're going to now mark this row in our table as being processed, because we're going to say our variable success, which is this one right here. And the reason I'm using the keyword variables is this defines any variables that have been declared, right? And the reason I want to use this is sometimes it's possible that this name, instead of being processed, is simply a flag called success. And we want to make sure that we're not just assigning the same value in the column to itself, right? We want to make sure that we use this keyword to indicate that this is the variable in here. We want to define what the scope is. And we're using the current row ID in our cursor, in our loop, to identify this and then update that row. Any questions so far? Do other people here in the audience have processes that they need to keep track of and that they need to have processed in a restartable fashion? How applicable is this to what you do? So, kind of think about it. Let me know in the chat if this is something that's applicable to you, or you already do this in your systems. And once this runs, we're also going to be doing some logging here, right? So let's see how this works. Let's look at our masterclass. We can see what the API calls are here. We're successfully going through, making calls to the API. And there we go. We got an exception. And we can see what the exceptions are and how they're being logged. And the nice thing about what we did here is that this is fully restartable. So if I stop this, you can see here that the last API call was 43. And now when I go to resume this, it's going to pick up on number 44, 45. We had an exception, and 46 is the next one here. Right? So this is our intro to restartable stored procedures or processes. The next one we're going to look at is caching stored procedure results. So I don't know if any of you have this problem where you might have a stored procedure that takes a particularly long time to run, and you can't really calculate all the permutations, and you can only store, or you only need these results periodically, right? So what we're doing here actually is when we make a call to the stored procedure. This is a very simplified version. If this is applicable to what you're doing in your business and you need to cache the results of stored procedures, please reach out to me. Send us an email at Data Virtuality, and I will happily set up a session with you and we can kind of go through and discuss more in detail. And I can also post this to the community if this is something that's applicable. So please let me know. What we're doing here again is setting up our logging. And what we're doing here is we're using our concatenation, and we're concatenating all of the parameters, the input parameters to this stored procedure. And we do this because we're going to use this as a key in our system, right? We're going to then hash these. So it's a nice small string. And we're going to check if this table exists in our Sprott cache. If it does, then, whoops, I forgot to create our Sprott cache. And if it exists inside the Sprott cache, then this is going to be retrieved from the Sprott cache. And if it doesn't, it is going to be inserted into the Sprott cache, and then we're going to read it out. Right. So it looks like I made a mistake. I forgot to create the Sprott cache here. So let's do this. Here we go. So let's create that table now. Make sure it exists. Now we have a table here. You can see this wouldn't be done in production. We would only have the hash parameters. We wouldn't have the concatenated parameters. And now we have the values that we want to cache, right? So let's say that this is calculating performing some very complicated calculation, and it takes, say, 5 minutes. And the users routinely query this over and over again, and each time they have to wait. So what we're going to do is, as we can see here, our Sprott cache is currently empty. And the first time we run it, we're going to cache the results here. And we are returning the values here, right? And if we look, this value has now been cached. Right? And we're basing this caching on the results, right? So the next time we run this is actually the results are being retrieved from our cache. It's not actually going through and recalculating this. So the next time I then run this one, and because it returns the same results, but if we look now at our cache, what it's doing is it now has a separate entry. Why? Because the parameters that were passed in have a different signature, so we're caching this again, right? And again, in production, if you were to use this method, you would have a timeout or a time to live that would indicate how long this cache should live. And again, other things that we could talk about. So let's execute all 4 of these statements. So we can see here, now when we look at the stored procedure, we look at the contents of this table here, we can see that there are now 4 different rows. And there correspond to 4 different rows. You can see there's duplicate data, but we have 4 because the signature is different in each one, even though we're only using the first parameter and that's going to define our row, we are using that as a different cache. Right? So if we ran these again and we had a system that took a long time, say each call to the stored procedure took 5 minutes, these next calls would return almost immediately because we're looking at them inside of cache. And that concludes our presentation. I believe we're almost toward the end. Can we double check here?
Yes, that is correct. Now 5 minutes left from the official timing.
So I'd like to open this up for any questions, feedback that you would have. Colin has a question. Can you create a chain of atomic jobs? Yes, you can. Again, the outer transaction is really the one that is most important. You'll have the smaller transactions inside, but if your outer transaction fails, it is going to revert or roll back all of them. So your outer transaction is really what's going to take place, what's going to take precedence, excuse me. And also, to my knowledge, we don't currently support nested transactions. So the outermost transaction is really the one that's going to take priority or take precedence.